Hello and welcome to my channel. I am Ensan Augustine. In this lesson, we're looking at how to evaluate limits graphically. And what we are going to look at is how to graph this piecewise function and use it to solve some limit questions. So join me as we graph this function. Now, for this function, if we consider f of x for x less than 0, then f of x equal to square root of negative x. Now let's take some values less than 0. We have negative 1 is less than 0, negative 2, negative 3 going. We also have negative 0.1, negative 0.002. They are all values less than 0. But let's consider these three whole numbers. Now for f of negative 1, you will get square root of negative 1 minus 1 is 1. So square root of 1 is 1. For f of negative 2, you get square root of 2, and that will give us 1.4, two significant figures. For f of negative 3, you get square root of 3, and that will be 1.7 to two significant figures. Just put negative 3 here, you get negative 3. Negative is positive. If you put negative 2 there, negative is positive. That's what I've done. Okay, use your calculator to check these values. So here, if we take f of x equal to square root of negative x, that is considering x less than 0, the pair of values that we are going to get are negative 1 will give us 1. Negative 2 will give us 1.4. And negative 3 will give us 1.7. So let's print this and then write it there because I want all these things to be there. So you have negative 1 will give us 1. Negative 2 will give us 1.4. Negative 3 will give us 1.7. Okay. Now, if we consider x greater than or equal to 0 but less than 3, that is from 0, 1, 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, 2.999. So these are the values between 0 and 3, including the 0. So you look at this one, you take f of x to be equal to 3 minus x. Well, that's the definition there. So if we take f of 0, you get 3. If we take f of 1, you get 2. 3 minus 1 is 2. 3 minus 0 is 3. If we take f of 2, you get 1. So for this one too, we are going to get this pair. We are going to get 0 will give us 3, 1 will give us 2, and 2 will give us 1. Wow. So 3 values are okay. Now let's take the last one. For x greater than 3, f of x is equal to x minus 3 all squared. And let's take just 3 values. Let's take x equal to 4, because 4 is greater than 3. 5 and 6. Let's take these 3 values. If we take f of 4, 4 minus 3 is 1. 1 squared is 1. If I take f of 5, 5 minus 3 is 2. 2 squared is 4. If I take f of 6, 6 minus 3 is 9. 3 squared, 6 minus 3 is 3. 3 squared is 9. So here to I'll get 4, 1, 5, 4, 6, 9. So let's see how we plot these points on the graph. Now let me draw my graph here. Now you see that the highest power of f of x is 9, or y is 9. And then we don't have even a negative. Yeah, we have negative values of x, but we don't have negative values of y. So we can just let our graph come to this side. Yes, so that we use the top here for the positive values. And here let us extend this one. So here let's put here to be 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3, negative 1, negative 2. Here to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's look at this point first. Negative 1 is 1. So negative 1 is 1. Negative 2 is 2.4. It's 1.4. So if we indicate here as 1.5, then 1.4 or somewhere be here. Then negative 3 is 1.7. If this is 2, then 1.7 or somewhere be here. Okay. But we have some values between negative 1 and 0 that we did not plot. So let me put the 0 there. This is 0. And here we have x less than 0, which means 0 is not included. So we use open circle there to show that 0 is not included. So let's draw foul. Let me draw it very neatly. So we have the 1 here. Correct. This one will make. Okay. The 0 is not included. Now let's take the next one. The next one, we are having these values. 0 is 3. 1 is 2. 2 is 1. 2 is 1, right? Wow. 1 is 2, 0 is 3, 2 is 1. But this one is 2 is 1. We do it like this, huh? Okay. And this one too. We have the one somewhere here. Yes. So here we have 2.9999. So the values between here we do not plot them. And here we are saying that this 3 is not included. So let's do a hole there. And draw the straight line to touch the hole. Let me stand there and draw. Wow, this is a straight line. Wow, that's a straight line. Okay, now let's look at the last one. 4 is 1. So 4 is 1. This is 1. 2, 4. 5 is 4. 5 is 4. And 6 is 9. This 6. And this is 9. So let's draw. And here we are saying that x is greater than 3, meaning that 3 is not included. And there is a hole there already. Wow. So that one is a curve. that one is a curve, and this one is a straight line. So that is how we draw the graph. Very simple as that. So let's use the graph to answer the following questions. We are saying that we have to use the graph to evaluate this. We have to evaluate the limit of f of x as x approaches 0 from the right, and b, the limit of f of x as x approaches 0 from the left. And c, we have to find the limit of f of x as x approaches 0. So now let's look at that. As x approaches 0 from the right, x is approaching 0 from the right. So let's trace this line up, trace it up, trace it up. You see that the value will approach 3. So here this value will approach 3. That is positive 3. Now as x approaches, oh wow, let me indicate the line. This curve is not a line. This curve is y equal to square root of negative x. This line is y equal to 3 minus x. And this curve is y equal to x minus 3 squared. Wow. So let's use them here. As x approaches 0 from the right, we are going to use this straight line. The limit of 3 minus x as x approaches 0 from the right, and it is 3. Wow. As x approaches 0 from the left, f of x, we are going to use this curve. You see that this curve will come and land on the 0. So if you want to trace this, you trace it where? It is still on 0. So this one, it will be 0. Because if you trace it, it will go here, it will go here. But as x approaches 0, you see that the function will also come to 0. Now what can we say? We say that this limit does not exist because the left hand limit is not equal to the right hand limit. And I forgot to write that here we use the limit as x approaches 0 from the left of square root of negative x, and we are getting 0 because we use this curve to do this one. So here the limit does not exist because the left hand limit is not equal to the right hand limit. Now the next example is that we are to use it to find this. We are to use it to find the limit of f of x as x approaches 3. So how do we do this one? So you see that this line goes to 3 and this curve also comes to 3. So as x approaches 3, we have to look at the left hand limit and then the right hand limit. So we are going to take the limit of f of x as x approaches 3 from the right, and the limit of f of x as x approaches 3 from the left. So now from the right hand side, let's see. As x approaches 3, you see that it gets to 0 because the point will come and lie on the x-axis, and if you trace it here, you are getting 0. Wow. So here you use the limit of x minus 3 all squared as x approaches 3 from the right, and it is equal to 0. And as x approaches 3 from the left, you see that it comes to the same point, and if you trace it back here, you come to 0. The 0 is the black marker. This one is a hole. So this one too, we are going to use the limit of 3 minus x as x approaches 3 from the left, and that one too will be 0. So we can conclude that the limit of f of x as x approaches 3 is equal to 0. Learn how to draw the graph and learn how to interpret the graph when you are given any similar question. Thank you for watching, and please subscribe to my channel. Bye bye.